Welcome to this presentation on elasticity and Hooke's law. We will explore the basic concepts, the role of spring balance, Hooke's law, and step-by-step calculations using real-world examples. Elasticity refers to the ability of a material to return to its original shape and size after a deforming force is removed. It is an essential property of elastic materials like rubber and springs. Let's look at three important concepts in elasticity. The elastic limit is the maximum force a material can take and still return to its original form. The yield point is where the material starts to change shape permanently. The breaking point is when the material breaks apart due to the applied force. Hooke's law states that the extension of a spring is directly proportional to the applied force, as long as the elastic limit is not exceeded. This diagram shows a spring being stretched under increasing force, demonstrating Hooke's law. In the first position, no force is applied, and the spring remains in its natural length. In the second position, a force F is applied, and the spring stretches by length x. In the third position, the force is doubled to 2F, and the spring stretches by 2x. This shows that the extension is directly proportional to the force applied, confirming Hooke's law, F equals kx, where k is the spring constant. Mathematically, this is written as force equals spring constant multiplied by extension, where F equal to force k equal to spring constant and x equals extension. Let's take a look at our first example. If a force of 0.9 n stretches an elastic spring by 15 centimeters, find the elastic constant of the spring. We will be calculating for the spring constant. A force of 0.9 newtons stretches a spring by 15 centimeters. Convert the extension to meters. That is 0.15 meters. Our force is equal to 0.9 newton. Using Hooke's law, force equals spring constant times extension. Rearrange the formula to get spring constant equals force divided by extension. 0.9 divided by 0.15 equals 6 newtons per meter. Let's solve our second example. A load of 5 newtons gives an extension of 0.56 centimeters. What is the extension caused by a load of 20 newtons? Since extension is proportional to force, we set up the ratio. Extension 2 divided by 0.56 equals 20 divided by 5. This gives 4. As 20 divided by 5. Equation becomes extension 2 divided by 0.56 equals 4. Multiply both sides by 0.56. The extension is 2.24 centimeters. Let's take a look at another example. A material of length 150 millimeters is stretched by a force of 7.4 newton to 175 millimeters. Calculate the elastic constant of the material. In this example, we are given the initial and final lengths of a material. Subtract 150 from 175 to get the extension, 25 millimeters. Convert it to meters, 0.025. The force is equal to 7.4 newton. Apply the formula, spring constant equals force divided by extension. 7.4 divided by 0.025 equals 296 newtons per meter. Thanks for watching. To deepen your understanding of any topic, explore our comprehensive resources, including revision notes, past questions, gamified quizzes, and workbooks. These tools are designed to help you master the concept effectively and enjoyably.